Hello everyone and welcome to the fifth lecture and new chapter. Sorry, it's not chapter 3, it's chapter 2. We are just done with chapter 1 and we have just started our new chapter. It's not 3, it's chapter 2. Okay, design of irrigation canals, or you can say it, design of irrigation channels or canals. Okay, so before going into the designing section, we need to discuss few very important things related to designing, because before starting the designing process we need to know some important points. Okay, the first and most important thing is that, as a note, you can write it down. Make a note and write few important points. Note, and you can write some important points like we need to actually, do you know that we need some efficient or economical system to take water to the field? Because if we do a random excavation, that is also a canal, but designing means that we should make a system which should be efficient. Okay, and by efficient, what do you mean? Efficient means if you do the proper designing of the canal, then there will be minimum evaporation losses, right, and seepage losses. So we need to make an efficient system. For that we need designing. And the other important point is that we should reach to the destination point in the shortest possible time. Like from source to the field, if we want to provide water to the field from the source, then we will design canal in such a way that it should take the shortest possible time. So for that we also need to do the proper designing. So actually we are discussing the importance of designing any sort of canal, and we know that crops have a fixed requirement of water, and it depends upon the type of crop too. So the point is that there should be feasible size of canal. That means we need to properly design and define the width, height or depth, and slope of canal, right? So, and the next point is that cross section, and other important point is that the cross sections of any canal can be either circular it can be maybe square, it can be rectangular, or it can be trapezoidal. Okay, and the most used section is trapezoidal section. This is mostly used for the designing of canal, and it is considered as the most efficient cross section. So these are some important points, and they are showing that why designing an irrigation canal is important. Because if you do just some sort of excavation to take the water from the source to the field, that is also called canal, but that is not properly designed. If it is not properly designed, then that will be not efficient canal, and there will be operation losses, there will be seepage losses, and it will take longest route, or it will take more time, right? And the dimensions of the canal, width, depth and slope, are also not properly selected. It will also affect the end results and will cause the wastage of the water. And the selection of cross section of canal is also important. So for all these points, we need a proper designing system. We need proper design approach. Got it? So the next point is that we need, before starting the designing, we need to know what actually a canal is. Definition of canal. Okay, so how can you define a canal? Let's say, let me choose a different color to write the definition of canal. So we can define canal as, canal is defined as a structure constructed to carry water from source, carry water from source. What can be your source? Source can be either a river, or it can be a reservoir, any sort of reservoir, right? Reservoir. So canal is defined as a structure constructed to carry water from source to the agricultural land. For what? For irrigation or any other purpose. So that structure is called canal. Got it? So generally we use a trapezoidal section. Trapezoidal section is considered, or it is adopted for canal design due to its satisfactory performance. Satisfactory performance means there will be less evaporation and less seepage if your cross section is designed in a trapezoidal form. So you can note down this point too. It is actually important point. So generally what we do, generally trapezoidal section is adopted for canal design. What's the reason? The reason is that due to its satisfactory performance. Okay, what do you mean by satisfactory performance? Satisfactory performance means there will be less evaporation and less seepage in the canal if you design it in a cross section in trapezoidal shape. Okay, so that's the point. The next point we need to discuss is about the what is canal irrigation system. What is a canal irrigation system and what it consists of? So we know that from river to reach the water, to take the water from river to the end where the water is required, like field, there are various components through which the water passes and reaches to the field, right? Let's take an example and draw a figure to make things more clear. Let's say we have a source here which we call river. Let's say this is my river, right? This is a river, and from river there will be a branch. From here, from the source, we will take water. We will call this, what we will call it? First, let's draw the figure and then we will define each component. After that, there can be some branches from this. Let's say this is a branch. Another branch is here. Connected to. And then let's say there are a few more branches. And then from this branch we will take water through another canal system. Let's say we are taking water from here. Okay, and then from this we are further dividing this into another branch, and then from this we are, as you can notice that the size of every canal system is reducing from the source to the end. After that we will reach to the end point, which is our field, right? Let's make field with green. This is our field. So let's write down the names to these components. What is this? This is our source, which we call river, and then from river the water will go through what we call this one. This is our main canal, and then there will be another This is known as, let's write it out here, we will call this branch canal, and next one, this one will be our distributary, and this will be our minor distributary. In next video I think I need to reduce the size of the fonts. That will be, let's take it from here, minor distributary. Okay, and then what this orange, this is going to be our we will call it water course, and this will be our field. Got it? So I hope you got these points. Let me, this is our river, right? This is our river and water is flowing here. From river, this is our source. We call it also, we can call it source too, right? From source we will take the water to our main canal. This is our main canal. From main canal we have different branches. This is also branch canal, this is also branch canal, and this is also our branch canal. So from branch canal we will further take the water to another canal system, which will be obviously smaller cross section as compared to the branch canal, and this is called distributary. From distributary, the other branch which comes out from the distributary is known as minor distributary, and from minor distributary we will take water through the water course. This is known as water course, and this is our minor distributary, this is our distributary, and then the water course will take the water to the field from the minor distributary. So this is the canal irrigation system from source to the end field, right? So what is the actual distribution system on the basis of, so the irrigation system is divided into three main parts: primary distribution system, secondary distribution system, and tertiary distribution system. All these components are divided into three main categories: primary, secondary, and tertiary distribution system. So what are these three main parts? Let's check it out here. What is the first one? First one is primary distribution system. The primary distribution system consists of two parts. Number one is your main canal, and second one is branch canal. So branch canal and main canal falls in the category of primary distribution system. And then the next is secondary distribution system. First is primary, second is secondary distribution system. And in the secondary distribution system there are two components, which are distributory canal. Let me give it a number. First one is distributory canal and the second one is minor distributory or minor distributory canal, you can call it both. And the third one is tertiary distribution system, and it includes the first component of tertiary distribution is water course, and second is your field. Got it? So these are the three important components of water distribution system in any irrigation system. So the point to note here is that this primary distribution system is actually managed and maintained by state irrigation. This responsible organization for this is, you can write it like, it is managed and maintained by the government or state irrigation departments of any country, right? And secondary distribution system, this is also maintained and managed by the government authorities or the state irrigation department. But the tertiary irrigation system, it is being maintained and managed by farmers. This portion of irrigation system, this is maintained and managed by farmers themselves, right? So if you can see in this image, the structures which have been constructed from source, river. The first one is main canal, this is controlled by government. Branch canal, this is also controlled by a government, and these two fall in the category of primary distribution system, right? And the distributory canal and minor distributory canal, these two are also controlled by the government, and they fall in the category of secondary distribution system, right? And the third one, this has been water course and field are looked after, maintained and managed by farmers, right? And these two fall in the category of your tertiary distribution system. Clear? So this is the actual canal irrigation system which we got, and we need to remember and follow this while we are designing or constructing any irrigation system. And this source can be river, or either it can be any sort of reservoir to, like some sort of dam, right, or any barrage. So this was the introductory lecture for design of irrigation canals. We have discussed some important points related to design. We tried to show that why proper designing of an irrigation canal is important. The first point which we have discussed is that why it is important to design an irrigation canal. If we don't design it in an efficient or proper way, what are the consequences, what are the disadvantages we are going to face? We have discussed. After that, we have designed the canal. What is canal? How can we define a canal? And the most adaptable and feasible and recommended section for a canal is trapezoidal. As we know that we have other sections too, like circular, rectangular or square shape of canals too, but we prefer trapezoidal section, and it is adopted for canal design due to its satisfactory performance, which means if we design the canal in trapezoidal cross section, there will be less evaporation and less seepage, which is our main objective. And the next thing we have discussed is canal irrigation system. What are the different components? What is the composition of an canal irrigation system? So it starts from the river, which is the source, river or reservoir, which is the source. From the source, we will get our main canal. From main canal, we need to construct different branch canals, and then from branch canals, we will construct and take water through the distributary canals. From distributary canals, the water will go through the minor distributary canals, and from there, we will take the water to the field through water course. And here in water course, we will at the start here we need to put some sort of valves to control the flow of the water, to control the, which we call Q, flow of the water. We will place some valves here at the start of the water course, and we will open the valve according to the requirement of water to the field, and this field is our end destination. So we have divided this irrigation system into three main categories, right? The first was primary distribution system, which consists of our main canal and the branch canal, and then in second category was secondary distribution system, in which includes distributary canals and minor distributary canals. And the third one was tertiary distributary system, which consists of the water courses and the field. And we have also discussed who is responsible for the maintenance and management of these three systems. So for primary distribution system and secondary distribution system, the responsible authority is the state or government irrigation department. They are responsible for looking after and managing and maintaining branch canal, main canal, distributary canal, and minor distributary canal. But for the water course and field, the responsible group is our farmers. Farmers are responsible to look after and for the maintenance and management of water courses and field. Okay, so this was a bit introduction before starting our designing phase, and the first lecture for this new chapter ends here. And in next lecture, which is our lecture 6, we will discuss about the classification of canal. Right, you have discussed about the canals, but how these canals can be classified. They will be classified on the basis of their source or supply of water. They can be classified on the basis of their functions, on the basis of soil conditions, on the basis of their lining, and on the basis of their alignment. So in the next video, in whole video, we will discuss in detail about the classification of canal. So till then, goodbye. See you guys in next video with our new topic.